Okay, so we're going to do volume between the curves. This is significantly more complicated, and it's also a huge pain in the neck to do these and plug them in. So this was like the area between the two curves. You have to know where they meet, and you have to know which one is on the top and which one is on the bottom. I don't like the way this marker is going. Try another one. So you have to make yourself a rough sketch. So look, y equals x starts here, and it's a line that goes like that, right? It has a positive slope, so it goes up. Now, 2 radical x also starts at 0. So what I'm going to do just for myself is, if I would have plugged the number 1 into there, I would get 1. But if I plug the number 1 into there, right, square root of 1 is 1 times 2. I would be up here. Now, the square root graph grows like this. Now, I need to know where they meet. They're going to meet somewhere out here. It's clear that they meet at 0. So you have to set them equal to each other. This step is not trivial. Now, a lot of people fudge their work here, which is not happening. So the technique to solve an equation that had a radical in it was to square both sides to get rid of the radical, right? You can't keep the radical there when you solve. Can you solve this in your head a little bit? Absolutely you can, but that's that's not work. That's, guessing and checking is not a solving technique. All right, so you would have to square both sides to get rid of the radical, right? Here you would just get 2x plus 1, right? You square the square root. So what I'm going to do is I'm going to square both sides of this to get rid of the radical. That gives me x squared over here. When I square this side, you have to square the 2 to get 4. When you square radical x, you get x. Now you set it equal to 0. Greatest common factor is x. Factor it out. So then you get x equals 0 and x equals 4, right? We're in Calc 2. We don't need to show that step there. So I know that I'm going to integrate, right? Now again, volume. There's a pi. I'm going to integrate between 0 and 4. Now this is the hard part. So, all right. So I made myself a rough sketch. Now you can see, I know I didn't draw the best graph there, but the square root graph is above that line between 0 and 4. If you go past that, the line ends up, right? The square root function does not grow very quickly. It's not like x squared. X squared is a parabola that grows very fast. So the square root graph does okay in the beginning, but then it really levels off. All right, so it's still a curve. The line eventually gets above it, but I am only interested between 0 and 4, which is where they intersect, right? You need where they meet. So just like you did, now if I were to take that shape and start spinning it, this is where you get the donut, right? You have this kind of, that shape. So it looks like a Pac-Man. So when you spin it around, right, this part is solid, but the middle part is open. So just like with the area, it's above, below. They don't call it that. They call it outer and inner, but it's the same damn thing. Look, this one is on the outer edge. This one's on the inner edge, right? I mean, a donut, if you picture a donut, you know, there is an outer edge. Look, there's the outer edge of the donut. That's what you first bite into. And then here's the inner edge. You get the outer one by the graph that is above. So the graph that is above is this dude. And remember, you have to square. So you're squaring the one that's on the top, and then you're going to square the one that's on the bottom, right? And you subtract them. That was how we did the area between. We took the area of the graph that was above, and we subtracted the area of the graph that was below. That's how we got the area between. So it's the same thing. You need the area between them first, and then when you start spinning it around, that's why the pi and the square is there. So it's not that different. Now, these problems are a huge pain because usually you get some really nasty things to integrate. You almost always get an x to the 4th. You're squaring. So if you have an x squared graph, which is a parabola, and you square it, you get x4. And then it just becomes monstrous to plug into. This one isn't that bad, so I'm going to do it all the way out. So first I'm going to square everything, right? I'm going to integrate from 0 to 4. I found that by setting them equal together. I drew a rough sketch so I knew that this one was on the top. This one was on the bottom. So now again, when I square that, I'm very careful. I get 4x. When I square that, I just get x squared. Now again, normally I would write this one first. I know people don't like to do this. I like to do this. I like to have the larger power written first. So that is a negative x squared. So I make sure my minus sign goes there. That's a positive 4x. And then dx, make my plus look better. Now I'm going to integrate, again, keep my pi. Add 1, divide, you're going to get negative 1/3 x to the third. Add 1, you get x squared. Divide by that, you get a 2. Again, I expect you to simplify these. Now, it's not so bad because when you plug in 0, there's an x, there's an x. There's nothing that doesn't have an x. So plugging in 0 is absolutely trivial. Get absolute simplicity here, right? Plug in 4. Now, this is the part where it gets to be a little bit of a pain in the neck. You can see the numbers start to get kind of big. Put 4 there. Minus 0. Why? Because 0 cubed is 0, 0 squared is 0, and anything times 0 is 0. So 0 kills the whole thing. So you just have to worry about this. 4 times 4 times 4 is 64. And don't forget there's a negative in front of it. And also, don't forget there's a pi hanging out waiting. 4 squared, 16. Double it, you get 32. Now, I have to make the bottoms the same. So you have to times this one by 3 over 3. So that's going to be 96 over 3. So you're going to get pi. This becomes 96 over 3. You're not going to be doing this part, by the way. Minus 64 over 3. I'm only doing it on this first one. And the pi is there. So you get 32 pi over 3. Hope that this is still visible. Yes, thank God. My camera doesn't quite go all the way to the bottom of the board. So you will be stopping here. Now, I computed that one because it's relatively straightforward to compute because one of the constraints, one of the numbers you're plugging in is 0. But I'm going to do a more complicated one, and you'll see that I'm not going to compute it all, and you'll understand why, and I won't make you compute it all either. So let me do another one. All right, so this time I jump to number 3. And again, I need some things before I even set this up. I need to know where they meet, and I need to know which one is above and which one is below, which one's on top. So I have no choice but to make myself a rough sketch. Now, I know y equal x squared is a parabola centered at the origin. And again, your graph doesn't have to be super precise. Now, this is a line. That is the y-intercept right there. That means it crosses at 6. So 2, 3, 4, 5, 6. Now, does it have to be super precise? No, it does not have to be super precise. I know, though, this is where people screw up. You have to know if the line goes up or down. A positive number in front of the x means that the slope goes up. A negative number means that the slope goes down, right? It's downhill, uphill. So this slope has a negative number. The slope is negative. So that means that the line is going to go down. Something like this. Look, I'm not going to be super duper precise. So this is the shape that I would spin around. I'm not going to draw it. It looks really bad when I draw it. So, but all I'm going to do on this question, all I care about doing is setting up my integral. You're going to see that this one gets very nasty. So first, I need to know where the graphs touch each other, so I know where to integrate from. Right? I'm going to put pi. I don't know this yet. I'm about to figure it out. I have to set them equal to each other. Now, you do have a choice. You can subtract this over to there and factor with a negative x squared, which I told you specifically not to do. Or you can take these over to the x squared, which is exactly what I'm going to do. I'm going to add the x over, and I'm going to subtract the 6 over, and set it equal to 0. Many people don't write this there. It is important that you write this there. This is an equation. You are solving for x by factoring. So the product of two things is 0. One of them must be 0. This is y equals 0. I am going to deduct a point if it's not there. I have not been doing that, but I will do that because you have to be very precise in this class. Now, the only pair that's going to work to give me 1 in the middle is 3 and 2. He has to be plus, he has to be minus. That tells me, right, you would have x plus 3 equals 0 and x minus 2 equals 0. So you would get x equal negative 3, x equal 2. That's where I'm going to integrate between. Those are my constraints. Okay? So I drew the graphs. Now, you're drawing them for 2 reasons. One, well, not really 2 reasons. I guess 1 reason. I was going to say to kind of see where they meet. But you should kind of sort of look and see if it makes sense. Like the numbers you got kind of fit the little BS picture that you drew. Now, you can see that where in between the points where they meet, yes, the parabola gets a lot bigger than the line does, especially because the line's going down. But between where they meet, the line is on the top. So he's on the top. So you're going to square him, and then you're going to subtract the one on the bottom. And this is where you can see it's going to start to get very, very nasty. Now, I'm going to times this out. I have pi from -3 to 2. Now, always, 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 don't do things in your head. You do things in your head, you make mistakes. My best students, my smartest students, write everything out. They make very, very few mistakes. It happens. But because they write everything out, they don't make a lot of mistakes, or they make no mistakes. So I'm very careful when I do these myself. Use 6 and 6. So again, make your rainbow. That's the real rainbow, the inner and the outer. You get -6x, -6x, that's -12x. And then -x and -x, when you times them, +x squared. And I have told you 100 times, I like to write them in order of the highest power starting first. This is just how I do it because it looks better. All right, 2, 1, none. So I write them that way. +x squared, -12, and then a +36. Now, when you square this, remember, you multiply, right? A power to a power means you times the powers. Although, technically, even if you did that wrong, 2 + 2 is 4, and 2 times 2 is 4. So even if you screwed it up and added the powers together, you still get 4. So now, that's it. If I were to take the antiderivative of this, I'm just going to show you because I'm not going to do it. And I am going to do it from highest to lowest. I would get -1/5 x to the 5th. I would get +1/3 x to the 3rd, right? Antiderivative of this. Add 1 to the power, 5. Divide by that, 1/5. Add 1 to this power, 3. Divide by that. Add 1 to that power, 2. Divide by that, you get -6x squared plus 36x. Now, and look at the numbers you got to plug in. You don't even have a good 0 there. This is ridiculous. I'm not even going to make you go this far. I am going to make you stop right there. Now, you must simplify the integral a little bit. I times it out. I'm not going to let you stop there. I want to see that you can get to that step, and then it's over. This is insane. I mean, I got 500 pi over 3. I don't think a single person in the class, when I was walking around checking this work, got that number. So I mean, it is beyond ridiculous for me to expect you to compute this by hand. Hell, even if you had a calculator, I mean, it might not do it right. So this is way beyond the scope of the course. I don't want that, and I don't even want an answer. I want you to go there. That's why this is very straightforward. You have a lot to do. You have to set them equal and see where they meet. You have to kind of draw a rough sketch like you did with the area between the curves, figure out which one's on top, which one's on the bottom, and you got to set up your integral. But when you get here, you're done. You're done. You already did a lot of work. You made a rough sketch, you set them equal, you found out where they met, you plugged them in, you squared them both, and then you simplified a little bit to this step. It's over. So that's all you're going to have to do. I'm not going to make you compute these integrals because they're monstrous and nasty as hell, and there's just no way that you can do these. I mean, it would take you a very long time, and you're probably going to do it wrong anyway. So, you know, this is my gift to the Calc 2 class, is that I let you stop here on this problem because it's very complex, and I don't want you to go beyond that. That's why I'm not going to do like a lot of these. You don't need to see more than this. You're setting up your integral and you're stopping. I'm not even making you do the antiderivative. Right? You don't even have to integrate it because there's no point. You're not going to plug in anyway. So that's how the question is going to be on the exam. All right. So again, hopefully you understand what to do here. It's not different. The formula is different, but it's not different than the area between curves. You do those same things. Rough sketch, set them equal, figure out where they meet. You're not going to be given that. You have to compute that on the side. All right. So again, good luck with that.